Hey everyone, and welcome back to another deep dive. You ever find yourself trying to learn something new,
Mhm.
and you stumble across those step-by-step examples? Today, we're going to dig into how we really learn from those things.
Right.
We've got this really cool collection of research that looks at when and how adding those extra explanations to those examples really helps us learn.
That's right. That's right. What we're talking about here is example-based learning, studying worked examples.
Okay.
You've got a problem, you see the solution steps laid out, and then bam, there's the final answer. It's actually a really common instructional method, and there's even this well-established idea in cognitive load theory called the worked example effect.
Okay.
Because it basically says that, when you're first starting out learning something new, learning from these examples is generally way more effective than just diving in and trying to solve problems all by yourself. Oh, yeah, I can totally see that. Like when you see how someone else is approaching the problem, you can sort of get a feel for it.
Yeah.
But what we're really curious about today, especially for you listeners who are all about learning thoroughly and efficiently, is whether adding instructional explanations to those examples really makes learning even better.
Right.
Like, does telling you why a step is taken, on top of just showing you the step, actually lead to more effective learning?
It's a good question. And the research that we've been diving into offers some really fascinating and actually somewhat surprising insights.
So that's what we're looking at today.
Exactly.
And that is the core question we're trying to unpack in this deep dive. We've got this meta-analysis, pulled together findings from 21 different studies.
All looking at the impact of these instructional explanations on those worked examples.
Yeah.
And our mission here is to break down what the research tells us and see if we can give you some actionable insights. Okay, so let's jump right in. One of the things that really jumped out at us as we were digging through this was actually the most surprising finding right off the bat. Across all 21 of those studies, the average benefit of adding instructional explanations to worked examples was pretty small,
Interesting.
an effect size of just 0.16.
So what does that kind of tell us?
So a 0.16 effect size, it suggests there might be a small advantage in some situations, but it's not a huge leap forward just because you have those explanations there.
Okay, so it's there, but it's not a game changer.
It's not this massive thing.
Yeah.
I think maybe intuitively, we might think that more explanation automatically equals better learning.
Right, more information is better.
Right.
That's what we think.
But this kind of small average benefit really highlights that it's not just about how much information you're getting, it's the quality of it and how you engage with it. That's way more important.
It seems like it. Yeah, and the research actually shows it's not a simple picture either. There was a lot of variation across those studies. Some of them showed a really big improvement from adding the explanations.
Yeah.
Some found no real difference at all. And there were even a few that kind of suggested that sometimes it might not even help to have those explanations.
To that, clearly the context matters.
Absolutely, the context matters. That variation is like the key. That tells us there are other factors at play here that really influence how well these instructional explanations work. And one of the first important things that the research kind of draws a line between is conceptual knowledge
Oh, okay.
versus procedural knowledge.
So if we think about that, conceptual knowledge is that deep understanding of the principles,
Yeah.
the why something works the way it does.
The why.
And then procedural knowledge is about knowing how to actually do something, the steps, the processes.
Right, the step by step. And this is where it starts to get kind of interesting. The meta-analysis showed that the instructional explanations, they tend to be a lot more helpful. When you're trying to really understand conceptual knowledge, they help build that foundational understanding of why things work the way they do. But when it came to procedural knowledge, that step-by-step how-to stuff, the extra benefit of explanations, it wasn't as clear.
So that's really useful for you listening, right?
Oh, yeah.
Especially if you're trying to learn quickly. But you also want that deep understanding. If you're learning a new subject, you're trying to really wrap your head around those core ideas and principles. Seeking out explanations along with those examples seems to be a really effective way
It is.
to build that strong foundation.
Exactly.
But it doesn't stop there. The research also looks at something called self-explanation.
Oh, I love this one.
Right.
Self-explanation is so cool.
I like the sound of this.
Yeah.
Self-explanation. So that's me trying to explain things back to myself.
Exactly.
Tell me more.
It is exactly what it sounds like. You're actively trying to make sense of that worked example by putting it into your own words. You could break down each step. You could connect the steps to the bigger picture. You could even try to predict what's going to come next and why. And here's the really cool thing.
Okay.
While having those explanations given to you can be helpful, They're not necessarily any better than if you just prompt learners to come up with their own explanation
Oh, wow.
in some studies. Encouraging self-explanation actually led to even better results.
So, me just trying to say out loud why that step is being taken or how it connects to the bigger picture could be as good or even better than just reading an explanation.
Potentially, yes.
That's powerful.
It is. Think about it. When you try to explain something, you have to really engage with the material. You have to pull up information, make those connections, really structure your understanding. And that deeper level of processing can be so beneficial.
Yeah. It's like when you're trying to teach someone something, your own understanding gets way better just by preparing to teach it.
Totally. And when we look even closer at the content of the explanations themselves, the research makes some cool distinctions.
Yep.
We can separate out the explanations that focus on the underlying principles, the why.
The why, versus the ones that focus on what are called operators. Those are the specific steps or actions that you take.
Right.
The how.
The how, yeah.
So like one type of explanation might go into the math rule or the scientific principle that supports that step, focusing on that why. And the other type might just say what's being done. Like next you multiply these two numbers, it's just focusing on the how.
Exactly. And the results here were a little bit mixed.
Okay.
One study showed a pretty big positive effect when the explanations focused only on those operators, those specific steps.
Interesting. But explanations that focused only on the principles, or even on both principles and operators together, they didn't show those big average effects across all the studies.
Yeah.
It's kind of counterintuitive, isn't it?
Yeah, you would think that getting both the why and the how would be the best combo.
For learning.
Right. But this finding actually shows us just how complex learning really is. Different explanations might work better or worse depending on a bunch of things, like the type of problem, what you already know coming in. More research is definitely needed to really figure out the specific impact of all these different types of explanations.
Okay, so we've talked about these instructional explanations on their own. We've talked about the power of self-explanation. What happens when we compare them head to head?
Right. Good question. The meta-analysis actually did that. They compared learning with instructional explanations to two other scenarios.
Okay.
Learning from worked examples with absolutely no help, and then learning with worked examples where people were told, hey, explain this to yourself.
Yep.
So what did that comparison tell us? Well, having those explanations definitely helped compared to having no support at all.
Okay.
So generally speaking, some kind of explanation is better than just giving you the examples with nothing else.
Okay. But here's the thing. The advantage of those explanations got a lot smaller when they compared it to self-explanation.
Yeah.
Again, it just shows us that actively working through those examples yourself is really crucial.
It seems to be a key component. It's not just passively taking in information. Even if it's really well explained, you gotta wrestle with it yourself. Make sense of it.
Yeah.
It's like working out a muscle. You can't just watch someone else lift weights. You gotta get in there and do it yourself.
So another question that the research looked at was whether the benefit of having instructional explanations changed if learners also got a chance to solve problems themselves
Right.
while they're learning.
So you see an example, you get the explanation, and then you try it out yourself.
Yeah. You'd think that would make it stick intuitively.
It seems logical. But here's the thing. The meta-analysis actually found no big difference in the effectiveness, whether or not they had that problem-solving practice.
Oh, wow. That's another one that goes against what you might expect.
Yeah, it challenges the idea that applying what you learn right away is always the best way to make it stick. It could be that those explanations are really building that understanding, but the benefits of actually using that understanding might show up later on in ways that weren't measured in these studies.
Okay, so we've been talking about learning pretty generally. Does it matter what subject you're trying to learn?
Yeah. Does the actual content make a difference? Absolutely. The research looked at studies in math, science, instructional design, and they found some interesting differences.
Yeah.
Like math studies showed a clear positive effect from those explanations. But in science and instructional design, it wasn't as clear-cut.
Interesting. So why math?
Well, there are a few possible reasons. Maybe people see math as tougher, and they need more help when they're left to figure it out on their own.
Okay. So those explanations could be especially useful there.
Exactly. Another thing could be the language of math. It's very formal and abstract. So having a clear explanation can really help.
Yeah, it can feel like you're learning a whole new language
Right.
with all those symbols and rules. So yeah, if you're tackling something difficult,
Hmm.
or if it uses a lot of jargon, those explanations might be really valuable.
Definitely, definitely.
Okay, let's think about how these explanations are actually given. Should they just automatically pop up,
Right?
default mode? Or should learners have to click a button to get them
On demand.
on demand?
Hmm.
You could argue that default makes sure everyone gets the information, but it might also be too much for some learners
Cognitive overload.
who don't need it
Yeah.
or aren't ready for it yet.
Mm.
On demand puts learners in control,
Yeah.
but do they really know when they need that extra help? So what did the research find?
So default explanations, the ones that just automatically appear, they did show a small but significant effect, but the on-demand ones, they didn't. However, and here's the kicker, there was no real difference in overall effectiveness between the two.
So even though default explanations seem to help a bit on average, giving people the choice of when to see them doesn't seem to hurt their learning,
Yeah.
but it also doesn't really make things better.
Yeah. Which is interesting.
It is.
It makes you wonder, how good are we at knowing what we need? How good are learners at judging their own understanding and figuring out when they need that extra explanation?
Yeah, sometimes you don't even know what you don't know.
Exactly. You think you get it, but then you try to explain it to someone or use it, and you realize, oh, there's a piece missing.
Exactly. So the research also looked at a bunch of other factors that can affect how we learn from these examples with explanation,
Right.
even though these weren't the main focus
Yeah.
of the meta-analysis. So what are some of those things?
Well, things like what's called the split source effect,
Okay.
which is when explanations and visuals, like diagrams, are presented separately. It makes it harder to learn because you have to do all this extra mental work to put everything together.
Okay. There's also the chance of redundancy. If you're adding explanations to material that's already really good.
Right. You might just be giving people information they already have.
Okay. And then there's the modality effect, which says that sometimes hearing explanations instead of reading them can be helpful.
It uses different parts of your brain.
Yeah.
And that can reduce the load on your visual processing.
So it's not just about whether or not you have explanations. It's about how they're designed, how they fit with the examples, and even how they're presented.
Exactly. Exactly.
So we've covered a lot of ground today. What are the big takeaways for everyone listening about using instructional explanations in example-based learning?
Okay, so first, instructional explanations can be a good tool, especially when you're trying to learn new concepts. The why behind the how.
Yes. But it's just as important to remember that you got to actively engage with those examples yourself.
That active processing is crucial.
Taking the time to try to explain it in your own words.
Self-explanation seems to be as good as, or even better than, just passively reading the explanation someone gives you. And the effectiveness of those explanations might not be the same for every subject. This research hints that in things like math, they might be more helpful. And lastly, just throwing more information at people in the form of explanations doesn't always lead to better learning, and it can sometimes even be counterproductive.
So, the best way to learn from examples probably involves finding that sweet spot between getting guidance and putting in the effort to understand it yourself.
Right, it's finding that balance.
Now, for all of you listening, think about how you can add more active engagement and self-explanation into your own learning routine, even when those explanations are right there in front of you.
That's such a good question to think about.
Maybe it's forcing yourself to pause after you read an explanation and try to say it back in your own words. Or maybe it's making yourself ask why at each step, even if it seems clear.
Yeah. Those are great starting points. Ultimately, the best way to learn is going to be unique to you. It depends on how you learn best, what you're trying to learn, and how far along you are. So keep experimenting and see what works.
Well, this has been a fascinating deep dive into the world of instructional explanations.
It has.
Thanks so much for joining us. We hope you found it useful.
And we hope it's given you some things to think about how to learn more effectively.
Absolutely.
Thanks for having me.
Thanks for listening. And we'll catch you in the next deep dive.